Assalamualaikum warahmatullahi wabarakatuh. In this time, we will explain about neural network. So, we have two members in our group. Members one is me. My name is Clarissa, Millenia, Zainal, Putri. And members two is Febi, Indriana, Fitriasari. So, in this video, we divide into two parts. Part 1 is about Hebbian and part 2 is about ADALINE. So, in this part 1, I will explain about Hebbian. Hebbian is one of the simple and old learning rule for neural network. Hebbian was introduced by Donald Mohd in 1949 and have proposed that if two interconnected neurons are brought on at the same time, then the weights between them should be increased. Hebbian network is a single-layer neural network which consists of one input layer with many input units and one output layer with one output unit. This is the Hebbian algorithm. First step, we can random initial weight. We can use random value to initial weight and bias. Second step is set the activation for input unit. We can use this formula. X equal to U. I in this formula equal to 1 to M, and M in this is amount of data. The third step is we set activation for output unit. We can use this formula Y equal to T. Y is output and T is the target. And the fourth step is adjust the weight for we can know the value of weight with this formula. V new equal to V out plus N times X times Y. In this case, N is the learning rate and the next step is adjust the bias. For if we want to know about if we want to know the value of bias, we can use this formula. P mu equal to P out plus N times Y. So this is the training algorithm of Hebbian. So we have x1, x2, x3, which is this is a input, and the input divide into two class A and class B, and we have value of t 0, 0, 0, 1, 1, and 1. So in this case, we have to find y, w1, w2, and w3 and bias. So if we want to get the value of y, we can use this formula. That is y equal to t. So if the t is 0, and then value of y is 0. So if the value of t is 1, then value of y is 1 because of this formula. So this is an initial condition of W1, W2, and W3 and bias. In this case, initial of W1 is 0.5, W2 is 0.25, and W3 is 0.2, and bias is 0. So if we want to get the W new or weight new, we can use this formula. W new or weight new equal to W out plus N times X times Y. In this case, N is learning rate are using 0.1. So we get this, the new of weight
0.5, 0.5, 0.5, 0.6, 0.7, and 0.8 from this formula, which is the same for week 2 and week 3. W2 and W3, we can use this formula too. So, if you want to know the value of bias, we can use this formula. B nu is equal to B old plus N plus Y. And then we can get the bias. So this is the bias nu 0, 0, 0, 0.1 and 0.2 and 0.3. So we get this weight and bias nu. This which one is 0.5, weight 2 is 0.45, and weight 3 is 0.4, and bias 0.3. So if we have to get this value, we have to know the equation of this value.
So, if we want to know the equation, we can use this formula. So, we have to get the y prime is same with the target, and we can get the value of y prime if the value of which height for the theta and y prime is 1. If the value of sum is lower than theta and y prime and the y prime equal to 0. So in this case, we can get this value of sum with this formula. Sum equal to x1 times w1 plus x2 times w2 plus x3 times w3 plus bias. So in this formula, value of w1, w2, and w3 and bias, we use this value. There is a 0.8, 0.45, 0.4, and 0.3 for the weight and bias. So this is if we have 0, 0, 0 for the input, and we can using this input to this formula, and we get the summation value of summation is 1.23. So 1.23 is lowest than theta, so y prime is 0. So this is if the summation value of the summation lower than theta, so the y prime is 0. So if the value of summation is higher than theta, so the y prime is 1. So if we look in this y prime, we can know that this y prime is same with the target. So the equation is 100%. A decision boundary. So if we want to make a decision boundary, we have to determine x1, x2, and x3 to make a line. So if we want to define determine of x1, x2, x3, we can use this formula. So the formula is x1 w1 plus x2 w2 plus x3 w3 plus b equal to theta. So we get this formula x3 equal to 0.75 minus 2x1 minus 0.25 x2. So with this formula, we get this value of x1, x2, and x3. If we assume x1 is 0, x2 is 0, then we get x3 is 0.25. So if we assume that x1 is 0 and x3 is 0, we get the value of x2 is 1.767. So if we assume that x2 and x3 is 0, and we get this value of x1 is 0.527 of 0.82775. If we have to get x1, x2, x3, we can plotting this x1, x2, x3 to make a decision boundary. So this is I plot this x1, x2, and x3 with this f. There is a GeoGebra classic. Red line is assumed by x1 and green line is assumed x2, and blue line is the assumed of x3. So with in this case with this data we can get this line K, K, and L. So with if we so with this line K, K, L, we can know that we have divided into class A and class B. So this is the optimal because this value of this line get to divide this class of E and P. So this is the optimal. So I will show you about if we return the data. So previously class A is 0, 0, 1 and 0, 1, 0 and 0, 0, 0, and class B is 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, and 1. So if we return the data, class A previously became to class B. Class B in the previously we became in class A. So if we return the data, the value of weight is the same with the before. So before if we get 0.8, 0.45 and 0.4 and bias 0.23, if we return the data, the weight and bias is the same. So the x1 and x2 is the same. So the plotting is the same with the previously. So that is my presentation. If any mistake, I'm sorry, and thanks. Assalamualaikum warahmatullahi wabarakatuh.
Okay, first of all, let me introduce myself. My name is Febi Indriana Fitriasari. Now I want to explain about the ADALINE or adaptive linear element. ADALINE or adaptive linear element was introduced by Professor Bernard Widrow and Ted Hoff in 1960. This ADALINE network are similar to the perceptron, but their element or the activation function is linear. It is a simple perceptron-like system that accomplishes classification by modifying weight in such a way as to diminish the MSE or mean square error at every iteration or at every epoch. And this is a ADALINE architecture. There is a input symbolized by x1, x2, or xn, and this is a summation, and that is a weight symbolized by w, and this summation will compare with the desired output and adjust the weight. And this is a threshold or theta, and there is a output. And the next slide is ADALINE algorithm. First of all, we must do the random initial weight. For example, W1 is 0.5, W2 is 0.7, or etc. And the second step, we must do set activation for input unit x equal u, where I is 1 to m. M is the amount of data. And the third step is compute the sum. We can know the value of sum by using this formula. Sum equal W1 x1 plus W2 plus W2 x2 plus Wm xm plus b. And the fourth step is adjust the weight. We know the value of weight by using this formula. W new equal W old plus n is learning rate, and times x times the mean sum. And the last step, we adjust the bias. To know the value of bias, we can use this formula. B new equal B old plus n times the mean sum. Okay, now I will use the ADALINE training to solve the linear problem. First of all, we have three input symbolized by x1, x2, and x3. And this input is divided by two groups, class A and class B. In this case, I use the OR logic regulation to know the target. Yeah. And this column is summation. To know the value of summation, we can use the formula x1 w1 plus x2 w2 plus x3 w3 plus b. After that, we can hold and drag. We can hold and drag until this data, like this. And the next column is the mean sum. T mean sum. Okay. To know the weight or weight 1 or W1, we can use this formula. W old plus n is the learning rate equal to 0.5 times x1 times the mean sum in each column, the mean sum. After that, we can use hold and drag until the dataset class B. Okay, like this. Yeah. For W2, we can use this formula. WO plus n times x2 times the mean sum. And for the W3, we can use the formula W old plus N times X3 times T min sum. For the next column is B or bias. We can know the value of bias by using this formula. B new equal B old plus N times T min sum. B old plus N is 0.5 times T min sum. T min sum is H column. And then to know the value of error, we can use the formula error equal T min sum square. Yeah, T min sum square. Okay. And then the last column, that is a summation of error. Okay, after we know the value of weight and bias in the last iteration, we obtain that W1 is 0.525 and W2 is 0.675 and W3 is 0.1 and the bias is 0.325. In this table, we use this value of weight and bias to know the y prime. Okay, y prime is similar by summation. Okay, x1 times w1 plus x2 times w2 plus x3 times w3 plus b. Okay, we obtain this value after we know the value of y prime for each dataset. We can determine the lowest range in class A and the highest range of class B to know the interval of theta. We obtain that theta more than 0.325 and theta less than equal to 1.625. After that, we can know the value of optimum theta by using this formula. The highest range of class B minus the lowest range of class A divided by 2 plus the lowest range of class A, and we obtain the optimum theta is 0.975. And then to know the equation of this particular case, we can use this formula. x1 w1 plus x2 w2 plus x3 w3 plus b equal to theta. The theta is 0.975. We obtain that x3 equal 9.75 minus 5.25 x1 minus 6.75 x2. After we know this equation, we can use this equation or this formula to determine the x1, x2, and x3. And in this case, I take two coordinates at beginning. x1 and x2 is equal to 0. If we use this equation, we obtain that x3 is 9.75. For the second example, if x1 is 0 and x3 is 0, so the x2 is 1.44. And for the third example, if x2 is 0 and x3 is 0, we obtain that x1 is 0.87 by using this formula. Yeah. If we plot the coordinate or this coordinate, we can, in this case, I use the GeoGebra Classic to plotting. x1 is symbolized by red line and x2 is symbolized by green line, and for x3 is symbolized by blue line. Okay, in this case, the data, this data is symbolized by using a white circle. So we can conclude that the line of plane divide the two groups, class A and class B, because the value of theta is optimum, so this plane can divide two groups, class A and class B. If we see in the top like this, or the beside one like this. This plane is divided two groups. Okay, if the data is reshuffled from the instruction given, we obtain that W1 is 0.23125 and W2 is equal to 0.34375 and W3 equal to 0.2020. W3 is 0.20625 and the value of bias is negative 0.04375, and then we obtain that the lowest range of class A is negative 0.04375 and the highest range of class B is the 0.7375. And then after we know the lowest range of class A and the highest range of class B, we can know the value of theta is equal to 0.35, and then we can use the value of theta to determine the equation, and we obtain that x3 equal to 1.7 minus 1.12 x1 minus 1.67 x2. After we know this formula or this equation, we can know the coordinate x1, x2, and x3 as some like previous line instruction given. Okay. If we plot this coordinate with GeoGebra Classic software, we can know that the plane of line is divided to group A and group B or class B. Okay, if we see in the top of side like this, yeah, top of side. In this case, the value of theta is optimum. If we see in the side one like this, the pen or slide is divided to class, class A and class B. Okay, in this case, I also use the MATLAB software to solve the linear problem by using ADALINE training. We can use the editor or the command window at the MATLAB. Okay, I try use the command window at the MATLAB. This function is to determine that the lowest value and the highest value of the target. And answer. Then the function of net will be saved in the workspace. And then we input the data set and instruction given and answer. This function is to determine the target, and this function is to initial condition of weight. W1 is 0.5, W2 is 0.7, and W3 is 0.8. Answer. And then net.b function. This function is to initial condition of bias as 1 equal 1. And then A equal sim net B. And then to training this ADALINE network, we have 3 input and we have 1 layer or the single linear problem or linear problem, yeah, and the output is 1. Epoch, in this case, there is a 1000 of iteration. To know the performance, we can use this toolbar and see the result. Base training performance is 0.0555 at epoch 1000. Okay, and then to know the difference of weight, you can use this function, and the result is this. And then to know the difference of bias, copy and paste here, and we know the value of different bias is 0.3341. This is to output network, and we can know the error by using this function. Okay, the result is this is. Okay, I think it's up for me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.